All right, we are moving on to composite solids. So I am on page 591 in your book, and I'm at the bottom of the page, and I'm reading volume of composite solid. So objects made up of more than one type of solid are called composite solids. To find the volume of a composite solid, decompose the figure into solids whose volumes you know how to find. So in other words, if you look at example 4, we have this cube, but then in the middle of the cube is a hole. And you can see that that hole goes all the way through. So if we were going to find out the volume of that shape, we would have to figure out the volume of the cube and then subtract the volume of that cylinder that is in the middle because that does not exist. So that's why we would have to use the volume of our two different shapes in order to figure out the volume of that figure we are given. So let's actually do an example in our book. We're going to flip over to the next page, so page 592, and we're looking at Got It D. I'm going to have you write down everything that I write down. So Got It D says the service club is building models of storage chests like the one shown to donate to charity. Find the volume of the chest to the nearest tenth. So if you look at that figure, we have two different shapes. We have a rectangular prism on bottom, right here. And then we have what shape is that? It's actually a cylinder, but it's a cylinder that we cut in half. So we're going to have to kind of do a lot of different steps to figure out this volume of the chest. So let's start with the volume of our rectangular prism. To find the volume of the rectangular prism, you take base times height times width. So our base is 25. Our height is 30. And the width of it is going to be 50. So I'm going to calculate that on my calculator. And I get 37,500. And it would be centimeters cubed because we're talking about volume. So that's just the volume of our rectangular prism. But now we have to figure out the volume of our cylinder. So if you remember the volume formula for a cylinder, we have volume equals pi r squared times the height of our cylinder. We are going to use 3.14 for pi, and we have to figure out the radius. So if I'm looking at my cylinder, that part goes clear across the circle, so that's the diameter, and if this is 25, that means this is also 25. So there is my diameter. Now we know that the radius is half of the diameter, so to figure it out, the radius, I would take 25 and divide by 2, and you should get 12 and 5/10. So my radius is 12 and 5/10, and we're going to square that, and then we're going to take it times the height of my cylinder. So if we were looking at the height of our cylinder, we would actually want to tip this figure over because that's how tall your cylinder would be right there. So if the bottom of that is 50, that means this is also 50. So the height of my cylinder is 50. I do order of operations first. So to solve, I'm going to take 12 and 5/10 squared, and I get 156 and 25 hundredths. And I still have to multiply that times 3.14 and times 50. So I'm just going to do all of that in one step. And I get a final answer of 24,531 and 25 hundredths. So that would be the volume of a cylinder. But I don't have a full cylinder there. I have it cut in half. So in order to figure out the volume of that, I would cut my volume in half as well, or divide by 2. So I took this and divided by 2, and I got 12,265 and 625 thousandths centimeters cubed. Okay? So now if I'm figuring out the total volume of that figure of my chest, I need to add the two different volumes together. And I get 49,765 and 625 thousandths centimeters cubed, but my last step is to round it to the nearest tenth. So my 2 tells my 6 to stay the same. So over here for got it D, my very final answer is 49,765 and 6/10 centimeters cubed. So you can see when we do composite shapes, those volumes and those steps just add up. And it takes a little more work, but it's not a lot of hard work. It's just keeping your work organized so that you know what you're calculating and what you need to do. We're going to do one more together. It's going to be on that next page. I'm going to be doing number 4. This is what number 4 on page 593 should look like for you. Again, as long as you're writing down the work as I do, you're getting part of the work done. All right, so number 4, an unused roll of paper towel is shown. What is the volume of the unused roll? So obviously right here, when you have a paper towel roll, you have a hole down the middle so that you can hang it up so that you can easily grab paper towels. So when we're figuring out the volume of the paper towel, we don't want to include the hole that's in the middle. So you can see that the shapes that we have there are actually 2 cylinders. So that one that I outlined in black, the hole, is a cylinder. And then the paper towel roll itself is also a cylinder. So we have to figure out the 2 volumes of the 2 different cylinders, and then we're going to subtract the smaller one from the bigger one so that we take out the hole that is missing. So let's just get started. So we know that the volume of a cylinder is pi r squared times the height of the cylinder. So if we did the big one first, down here at the bottom, they have that line going clear across, and they say that it's 12 centimeters. So our diameter is 12, which means our radius is half of that, or divided by 2. So our radius for our big cylinder is 6. So now I have the volume equals, I'm using 3.14 times my radius squared, so 6 squared, times the height of it is 26. So there that is. So then I would do orders of operation to solve. So 6 squared is 36 times 26 times 3.14. I'm going to do that all in one step. And I got 2,939 and 400 centimeters cubed. Okay, now if I'm finding the volume of that hole or the smaller cylinder, up here at the top you can see that that little red line goes clear across that tiny spot up there. So that is the rate or the diameter for the smaller cylinder. So the diameter for the smaller cylinder is 4 2/10, which means the radius is half of that, or 4 2/10 divided by 2, which gives you 2 1/10. So I use the same formula. The volume is going to be 3.14 times, get that work out of the way, my radius, which I found to be 2 1/10 squared, times the height of this cylinder is actually the same as my big cylinder, so times 26. So order of operations, I do 2.1 times 2.1, or 2.1 squared, which gives me 4 41/100 times 26 times 3.14. I do that all in one step and I get 360 and 324 10,000ths centimeters cubed. So now that I have the volume of my big cylinder and the volume of my smaller cylinder or the hole, I will take the bigger and subtract the smaller to get the volume of my paper towel. And I get 2,579 and 76 10,000 centimeters cubed. But the directions, do they say to round it to the nearest tenth? Directions do say up top to round it to the nearest tenth, so my final answer is going to be 2,579, because this 0 tells the other 0 to stay the same, centimeters cubed. So again, there's a little more work to that, but as long as you're keeping yourself organized, you should be able to just kind of follow the sequence and find your answer.